All right, hello everyone. This is instead of quiz. Obviously, quiz 8A was 8. I'm sorry, 9A is a survey. So instead of going over the quiz, I'm going to do a few more examples from the inverse trig that you might see on WebAssign. So, and if you're wondering why I'm repeating that, it's because now I'm on Twitch and everyone can see it. So now it's part of the recording. All right, so we've got these three kind of functions, right? And what we need to do, so we've got problems that look like this. So these are problems, I'm pulling these straight out of the book. They're things like the following. Find the exact value of each expression, right? And then it's got stuff like those are boring. It's got stuff like the sine. So let's do one of these that is similar to one that's in the book. So if I have the sine of, let's do arcsine instead. So if I have like the arcsine of sine of pi over 4, and then I've got stuff like arcsine of sine of pi. And we'll start with these two. So the important thing to remember is that I have this arcsine is not actually the inverse of sine, despite what the notation says, right? Arcsine is not the inverse of sine. Rather, it is the inverse of sine star. Okay? So if I look at sine star, I'm actually talking about this neighborhood here. Okay? So sine star is defined from negative pi over 2, inclusive of endpoints, to pi over 2, and it goes to negative 1, 1, right? So if I have a value between since pi over 4 is in this domain, is in the domain of star of sine star, I've got arcsine of sine of pi over 4 equals pi over 4. So in one sense, they cancel because I'm in the happy neighborhood. Okay? So 1 to 5, how do we feel about that? Let's see. 1, 2, 3, 4, 5. So what I mean by the happy neighborhood is this kind of happy zone, right? The happy zone for sine is the domain of sine star. Okay? So the happy zone for sine let me move this stuff out of the way here. I'll come back to it in a minute. Right? So what's happening here okay, this right here is the northiness. So this is the unit circle. And this is the northiness of theta. Okay? So if theta is here, right? If this is pi over 4. So if theta is here at pi over 4, my northiness right here is, so this is 1 up here, this is -1. This right here is 1 over the square root of 2, or the square root of 1/2. So, but I actually don't care what it is. Right here is pi over 4. And I mapped that to the northiness, but it's in the happy zone. So arc sine, so sine does this, and arc sine does this. All right, so this is what arc sine does. Right, if I'm in the happy zone, these things are inverses of each other, basically. Why won't it select the other? Okay. I've actually improved the backup plan, so I have a second tablet if this thing does weird stuff again, so I can switch. Okay, so because I'm in the happy zone, these are actually inverses. But let's look at what happens with pi here. With pi, oops, I'm not in the happy zone. Pi is not in the happy zone. Is not in the domain of sine star. So what's going to happen here is that sine is going to go here to 0, but arc sine is not going to go back here, right? Arc sine is not going to take me back. Arc sine is going to take me to here to 0. Right, so on this one, I could just say, hey, they cancel, but this one, they don't. Okay. Right, so sine star is only defined here because I had to restrict the function to make it 1-to-1 and onto. Okay. And that's in that lecture if you haven't seen it yet. But that's, if you haven't, you could pick up this little bit here. So how do we feel about that 1-to-5 out of the happy zone? Yes, lecture 8B, which I didn't do till last night. Right, I'm not in the happy zone. These are not true inverses. Right? We like to say, oh, arc sine's the true. No, it isn't. Okay. The same thing is true for cosine here. So we have cosine here, except that the happy place is different, okay? So the happy place for cosine is from, oops. It's the tool we have. It's supposed to let me set this to background, and it's not for some reason. I don't know. So the happy zone for cosine is this area right here. So cosine star is defined from 0 to pi to -1, 1. And its happy zone is 0 to pi. So it projects here, it projects down to the eastiness. I should make it project up, since that one make it a little bit nicer. It's going to take the C, isn't it? Okay, so if I have it project up, since that's a little nicer to look at. Come here. There we go. So here is the eastiness of theta. So let's look at this problem here. Let's say I've got the problem arc cosine of cosine of pi over 4. Well, pi over 4 is here. Its eastiness cosine is going to take me here. And arc cosine, because I'm in the happy zone, is just going to take me back. Right? Pi over 4 is in the happy zone. So I just throw in here, I get pi over 4. Now, compare that to something outside the happy zone. Let's do negative pi over 4. Right, so negative pi over 4 is outside of the happy zone. So I'm going to shift up. But now arc cosine is just going to take me back. So in other words, I could think of this as the arc cosine of negative pi over 4 equals the arc cosine of the cosine of pi over 4. Or I could think of it this way, arc cosine of the arc cosine of the square root of 1 over 2, right? Because negative pi over 4 is not in the happy place, but pi over 4 is its happy place equivalent, so to speak, right? They have the same eastiness. This right here is going to be this. For another example, let's do arc cosine of this point here. So that is pi plus pi over 4. Whatever that is. So that'd be 5 pi over 4. And that equals, so what I'm going to do is I'm going to map this up to the place that's in the happy zone. So in the happy zone, this is not in the happy zone, but this one is. So this cosine's equivalent, I'm sorry, arc cosine of that. I'm miswriting the problem. Okay. Here's 5 pi over 4, and 5 pi over 4 is not in the happy zone, but I meant that to be light purple. But 3 pi over 4 is, and they're equivalent. Okay? So 1 to 5, how do we feel about that? Let's see. How can I do that? Nope. Wrong window. So many windows, so little time. So what I'm doing, so to solve these problems, and the whole point of these problems is that it makes you think about what these things are. It makes you think about the fact that these are not true inverses. Arc cosine is not a true inverse for cosine, right? Because cosine's neither 1 to 1 nor onto. I have to kind of make an equivalent. Okay? And you actually don't need to memorize the whole unit circle. You only need this point, this point. You only need these points and be able to get through them, right? So if I've got this right here, if I know I'm here or here, right, for these problems, if I know I'm somewhere like here, right, I just go up here and do, instead of 3 pi over 2 plus whatever, I do pi over 2 minus whatever. I just find the equivalent. And it really helps to draw them out. That's the other thing I could say is the visualizations really help. Okay, tangent's happy zone is right here. Tangent's happy zone is from, if I do this, will it? Nope. It's not going to let me do anything. Tangent's happy zone is right here. It's the same as sines, except it doesn't include the endpoints. So the tangent, the thing with an actual inverse is defined from negative pi, the domain of tan star, which is the one that actually has an inverse, is this. And then, of course, the codomain is all of R. The target is all of R. Because tangent actually is onto. Okay. Any questions about that? So, like, one of the hard problems for this one is 5A on page, oh, you don't have page numbers in your book, on section 3.5. So, let's look at that one. So, the tan star of, the tangent of arctan, the arctan of tangent, let's do this one. The arctan, this is a little different, of tan of, I need something that's not going to wind up there, 7 pi. Okay? So if I go 7 pi around my unit circle, I wind up here. All right, is everyone on board with that? So I'm going to wind up here, right? 1, 2, 3, 4, 5. It's the thing actually showing 6, 7. Well, that's the same as the arctan of tan of pi. Right? Now I need the equivalent here. So I'm going to go here. And watch out for tangent, because it can be a little confusing. So remember that on tangent, I go opposite. So if I'm here, I go here. For tangent, remember I go to the opposite end of the circle. Right. So, for instance, arctan of tan of what point is this? Did I already say 5 pi over 4 equals arctan of, now the opposite end of the circle is that point there, so that's the tan of pi over 4, which equals pi over 4. So that's just a little review of some of this pre-calc stuff. So to find the happy place, let's just write it out. Okay, for sine, I go to the right. For cosine, go to the top. For tangent, go to the opposite side. Okay. So 1 to 5, and I know that's kind of a very brief review of the pre-calc. That not everybody remembers because it kind of comes at a time in pre-calc that's kind of annoying. But just to find this happy place equivalent, what I kind of do is I go the opposite. So again, that's just a quick review of the pre-calc that you may or may not remember. And if you have more trouble with this as you do the WebAssign, I don't want to make it seem like this is all it is. I just wanted to make sure that the pre-calc just kind of was in there. So if you don't remember all of the pre-calc, that's okay. But let's just review it. Let's make sure that it doesn't, let's review the highlights of it and make sure it doesn't trip you up. I once heard it said, and I've said it myself, that the hardest math class you'll ever take is the first one you actually care about, because then you have to go back and fill in all the holes from the previous math classes, right? So if you were fine getting C's forever and then all of a sudden you want an A, you now have to go back and get all the stuff that you missed before. All right, are there any questions on this stuff? Okay. So this is the 11 a.m. review. For the 5 o'clock review tonight, I'll do some more examples of the triangle trick. But I wanted to make sure, so it'll have a different set of examples and a different kind of little mini topic. But I just wanted to make sure that you guys were up on this. And I wanted to get your response for how comfortable you were with some of this material. so I knew ahead of time. So I wanted to ask it now I wanted to ask 1 to 5s now instead of in the recorded lecture where, there's only 4 or 5 people attending. Okay. Any questions for me? All right. So I'm going to stop Twitch here.